Okay, so welcome everybody. We're going to start off with Jimmy Phelan, and he's just going to give us a little bit of background to what he's done to create a better energy use in his own home.
Well, just to let you know, I'm very new to this. I have my solar panels in now for, I think they went in May last year. And to a certain extent, I think this is like magic, really. I'm very, very impressed with what I have and what I'm getting out of it. There's a lot more I can get out of it, but so far, it's been a pretty good experience from my point of view. And I just wanted to, in case people don't know what it's all about, I'll just give you a very quick show off what mine looks like and where we're coming from with it, if you don't mind. Just hang on out for a minute. This is all. This one. Okay, well, this is my actual setup. I have 16 panels, as I said. They went up May last year. 3 guys arrived one morning about 8:15. They went straight up on the roof, and they had all the panels up by about 12:30 in the day. Then they were gone. They had all the wiring done. As you probably know, there's battens under each, 2 battens under each panel bolted into the joists in the roof, and the panels clip onto those. I've had no problems with them whatsoever. I washed them down once with a long brush, and that's all I did with them, basically. The installation was completely painless. And the second part of the installation was the electronic end of it, which is this. So this is my inverter here, which converts electricity, and this is my battery. At the moment I have a 2 kilowatt battery, but this thing will hold a 5 kilowatt battery, and it's something that I'm looking into at the moment, of expanding the battery, because it's probably just not enough, because it's especially this time of the year. But I could do it more, and because I am producing a lot of power into the system. I was just checking earlier on about my things for today, and I think at one stage today I was up to 5.1 kilowatts production power. Mine has a maximum output of 5.68, I think. So the guys came, they plugged it all in, they did all the work. The electricians came about 3 hours after the guys arrived initially, and they were gone by 6 o'clock. I had absolutely nothing else to do. The system was in, and it started producing electricity from the very beginning. Most people, quite a lot of people around where I am here were interested, so I was giving demonstrations and showing people what it was all about. And there's an app on the phone which is very handy, and it gives me great assurance sometimes when I'm looking at things. It kind of cheers me up to know there's something happening, that I'm getting something for free. It was very interesting at the beginning because my old electricity meter was a Siemens, and it had the ability to go backwards, which was absolutely fantastic. Unfortunately, the ESB didn't think that, and they came and gave me a nice new smart meter in place. But I stalled them for a while, but I wasn't able to. They're all on about security and safety and all this thing, so I had to take this smart meter. But I did check it at one stage when I had the meter that went backwards, and on one Thursday morning, my meter read 798 units. And on the following Thursday at the same time, it read 740 units. Now that was a good week during the summer. So like if I was getting in other words, if I was getting all that power back for myself, I would have been in a negative charge for that particular week, which would have been a great plan really, as far as I was concerned. But it appears that the ESB people, and they were very insistent, and I had to, well, in theory, I probably could have fought them, but it didn't really. I'm not into that kind of hassle really. So eventually I did actually let them go and take out the meter, and they were very happy with themselves once they got rid of my meter, which they took away with them as well, unfortunately. Anyway, they were the good old days. So this was just to show people, this was the 29th of March, which is a good day. So if you can see this thing here, you can see this is my power generation. So I started generating power just as the sun came up, basically, just before 9 o'clock. And I was still, and I stopped generating power at 2100. hours, and you can see that the maximum I did that day is 4 kilowatts basically. So now this thing is not continuous. It only talks to the main system every 10 minutes or 15 minutes. So that's why there's blotchy bits in it here and there. But this was a big thing that a lot of people asked me, like how much sunshine did I need to actually generate power? But I just need a light. And as you can see, as soon as the light goes up there and as soon as the light goes off there, it works. So at the moment, it's working from roughly 8:30 until 8:30 really in the evening. So I'm getting a 12-hour hit out of it as such, like, you know. Now this is a more interesting one because this is my consumption. And you can see here, this is during the night down here, all the fridges and the various things that are on, and probably the television left on and a few chargers left plugged in. This here is when my son gets up to have his breakfast. So he uses a lot of power having breakfast. And this one here is my immersion. And then all these other peaks are, as you can see, lunchtime, tea time, various things that went on during the day. And then there's a kind of an underlying amount here of power that's been used all the time. So that's my consumption. Now, the thing with this one is you have to kind of make a mental picture of this one, because what I have then is I have this one, which shows the amount of power that I'm buying. So you can see before the sun came up, that one was still the same. That's when my poor son was going to work in the dark. And this one now is slightly less than in the previous one. And then during the day, everything I got during the day up until 6 o'clock basically came for free or almost for free. And then this was obviously the height of tea time, which only amounted to 1.4, whereas back here and the other one back here, tea time is looking at 3, almost 4. So this is what gives me the nice warm feeling, this bit here. So most days at this stage, it's down here now. Like obviously when the sun goes down, I'm back onto the boys screwing me again for electricity, but that's just my very simple summation of the whole situation. And obviously, as the days get longer, I'm going to get a lot more at this part rather than this piece here at the end. Even in the dark winter days, like, I know the days are much shorter, but even if I go back and look at some of those from way back, there's still a bit of this all the time. I'm generating something. I'm getting 10, 15, 20% of my power thereabouts from the panels every day. In the winter, it's not as good, obviously, but in the summer, it's fantastic. And as I said, in that one particular week in last year's summer, I was actually going backwards. Now, it just so happened that I'm changing my power suppliers at the moment. I'm doing a bit of investigation. And as far as I can see, and you guys probably know more about this than I do, that Amicitia appear to be the only people who are actually paying for power. You have to have the panels and you have to have the smart meter, and they're talking about paying 7.5 cents per kilowatt that I put into the system. So I would, from my usage, my estimate of my usage, that if I get that 7.5 cents per unit back, that would be over 500 euros a year to me based on last year's consumption. And I also did a quick comparison for this meeting on costs, and costs this year from March 21 to March 22. Costs this year are almost 35% below costs for the same period last year. Well, that's probably not going to hold up as well this year because the cost of everything is going to go crazy as far as I'm concerned. But this is what gives me even more joy now, because even if they are charging and I'm not buying, I'm very delighted with myself in that situation. So I've become a big component of these panels and what they can do. And as I said, I used a company called EcoVolt. They were very good. They were very efficient. As I said, that had all done in one day, and I've had absolutely no problem with it since. There was a power cut in our area a few months ago, and the system was down for the power cut naturally because it gets isolated once the power goes off. But I didn't have to do anything to bring it back up. It just reset itself once the power came back up, and it's been merrily working away ever since. I wish I had more little workers like it, really, like, you know. So that's all I have to say.
That's brilliant, Jimmy. You can stop sharing there. We'll take
Okay.
questions at the end if everyone is happy enough to, and we'll just continue on now. That was brilliant, and it's really good insight to get a personal kind of view of how you're benefiting for it, because I think that's what people like to hear, is the personal view as well. So thanks very much, Jimmy, for your time as well, and for showing us what it even looks like and the size of the units and stuff that's in the house. And so it's great.
As I said, I'm delighted with it so far, anyway, to tell you the truth, you know.
Yeah, absolutely brilliant. We'll move to Patrick then. So Patrick is involved with the SEC in Athenry, and he'll tell you a little bit about his project. If you can share there, Patrick.
Caroline, yeah. Hopefully you can see it all. You can all see that okay? Yeah, so I'm the co-founder of Amicitia, and we're a social enterprise based in Athenry, County Galway. And recently we kind of embarked on establishing a sustainable energy community in the town. And there's a number of reasons for that, which I'll kind of go through in a little bit more detail. But first, I thought it was quite interesting to look at actually where we're coming from in terms of energy. So this is 1 barrel of oil, and this is what you can get out of 1 barrel of oil. So all of the things that power everything around us, from our cars and our delivery lorries to the power in our homes, you know, even the wax for birthday candles. And I think the significance of the fact that it is just 1 barrel and then shows the number of outputs from that. And that extends to our everyday objects as well. So looking at the plastic around us, you know, from the plastic within t-shirts, or, you know, even hula hoops, or the toothbrushes that we use. So oil has had a significant part to play in the Industrial Revolution, and, you know, it's because of the cheapness and because of its being so readily available, it's made it very difficult for us to move away from these energy sources. And you can see that when we did a quick analysis for the start of the sustainable energy community, when you look at the level of use of fossil fuels to heat the homes in Athenry, and, you know, there's very little sustainability within our infrastructure in our local communities. And that's, you know, not necessarily true any one person's fault. It's just the legacy of this cheap fuel. And before we kind of became to realize how damaging it is to the environment, or, you know, we're already so deep into the system that it's very hard to change, but it gives a sense of the magnitude of change. And I think the solar panels are a great indicator of the kind of steps that are happening at the moment. And so when you look at these kind of large energy systems, the older systems, you know, they stem from a very centralized approach. So everything is kind of routed through large power plants, and they're delivered through large pylons and pipes. And it's very much you know, comes from an energy provider to a passive consumer. And I think James then is a very good example of the modern consumer, in terms of you're now actively participating in your energy consumption. You know, you're monitoring your energy consumption. You can see it going back into the grid. You can keep track of everything that you're using. And so it becomes more of a conversation almost between the community and where they're getting their energy from. And hopefully, as these conversations happen, we start to think more about our everyday actions and how, you know, we need to shift to more small scale kind of distributed sources of power. And we can see with the horrible situation in Ukraine at the moment, that over reliance on one form of fossil fuel to power our homes is just not a really good approach, because it creates one point of failure. And when one point of failure, then it drives up prices. So we need many more small producers, and we need them all working in their communities to kind of create this mix of energy, and that can lead to a more sustainable lifestyles for us all. So that's kind of the route that or the journey that we're on, if you like, within Athenry. So our social enterprise, we have a social hub in the center of the town. We started off, we do technology for older people and people with disabilities, and the profits that we generate go back to support community development projects. And so people use the social hub from disability groups, older groups, and this year we'll be transforming that into a community cafe. The idea there is to kind of generate projects that can bring the community together. And I think climate change can be that really good unifier of communities. And, you know, we're all working towards creating something more sustainable. And the Sustainable Energy Communities projects came out of SEAI. So they look to establish these sustainable energy communities right across the country, with the aim to be more energy efficient, look for more renewable sources of energy, and adapt to smart energy solutions within local areas. So there's quite a lot of these community groups all over the country, over 640 at the moment, and there's a wide range of organizations that have established these, from tidy town groups to kind of lots of rural towns, and right up to kind of county council level as well will be driving it. And there was a recent shift in the sustainable energy communities, and the way it's funded now, it's driven by the local authorities working with SEAI. So in the longer run, that'll be good, because previous to that, these organizations had to come up with match funding or bridging loans. So hopefully it will facilitate more and more groups to take these projects on, and widen the network. One of the great things of this particular network as well, since we've been involved, there's lots of shared learning and lots of experience across all the different groups, people showing the different stages that they're on with their projects, and showing the potential of it as well, because there's really tremendous potential when you start to see you know, projects that are more advanced and how well they're doing to bring lots of different community groups together and generate good energy mix within their communities. So yeah, ours is within Athenry. So as part of the initial establishment of the sustainable energy community, we had to kind of map out the boundaries of the area, and from there then another good element of the SCC program is that we get assigned a mentor. So the mentors have been really good in terms of giving us a sense of where our boundaries are and what we can do within those boundaries. So getting the data on the ground from the community and understanding the energy mix. So that graph I showed earlier, you know, understanding that the predominant energy is oil, and how then can we start to build out a plan to move away from that. So this is the initial kind of breakdown. It's more of a general kind of look at the town. So the population would be just over 5,000 people, with, you know, 2,000 homes or so, and the average spend there then is €1,900, and the kind of we get €15,000 of a grant then to run or to create an energy master plan for the town. So that's based on the size and the scale of the town, and with that €15,000, then we contract an energy specialist to come in and support us to create this master plan. So this is that's the journey that we've been on. We've kind of gone through the learning stage. And for anyone that is interested in setting up one of these sustainable energy communities, there's a real wealth of information online on the SEAI website, and they've done great handbooks, they've done great kind of step-by-step guides, and then the mentoring, as I mentioned, but also like monthly events and meetups that groups have just to share information. And that kind of helped us to get into the planning stage. So we're now just kind of at the planning stage. Unfortunately, there was a little bit of a delay with the plans just before Christmas. One of the groups that we had tendered to do the energy master plan actually pulled out of carrying out these master plans. And so we had to re-tender, and we're just waiting for the sign off on that now to kind of kickstart the master planning process, and develop out then from there to create like a project team that can carry this forward into the future. And then once you get past that planning stage and work with the groups to create the master plan, you can start to implement some of these projects, and you can start to look at other channels for funding. Thankfully, there's more and more funding coming on stream for energy projects, and it is becoming a little easier to get some access to finance. There's still a lot of work to do, particularly with kind of social finance groups and banks and everyone else that has to get involved. Credit unions are still kind of locked out of these markets, but slowly these things will come more and more relevant, and the urgency will kick in, and the realization that we have to do more and we're not doing enough, or at least I hope so. And essentially the master plan then is just looking at that baseline energy within the community. So everything from the commercial buildings to houses, doing some barrier assessments on the houses, looking at the kind of levels of energy use within the community, including transport, and we'll be speaking to some farmers in the community as well. And then from that, we can create a register of opportunities. So this works across kind of 3 levels. So it's kind of short, medium, and long-term goals for the community. In the shorter term, it will be kind of retrofitting homes and looking to kind of create warmer homes for people, and also potentially creating jobs. So Damien, that's on the call, there's supporting ex-offenders into employment. So can we mix these kind of new jobs that will be coming on stream because of this transition that we're making, and create employment for people from disadvantaged backgrounds? And then in the medium term, you're looking at kind of larger scale projects. Are you installing good amounts of solar panels across the community, looking at potentially solar farms that can feed back into community energy fund? And some groups are quite well along in this. So they've got solar farms and they're feeding back into the grid, but the money is going into the ownership of the community. So they're not kind of wrestling off grants and funds. They get a standard amount of money every year that they can track because of the energy that they're creating on site, and then that gets injected back into the community. And I think that's where the real potential lies with sustainable energy communities. And there's fantastic examples all across Europe of communities taking control of some of the finance that comes into their towns and villages. And so yeah, in terms of the SEC, it's like a lot of it as well is about creating that knowledge base and helping people to understand what it means to get solar panels on your house, or to put in some improvements and upgrades to create more efficiencies locally. But then starting to have those conversations around walking and cycling routes. There's a very active cycling community within Athenry already. Is there ways that the sustainable energy community can help support them going forward to, communities building their own cycle lanes through the funding that they can create through these things, and working, developing teams of people within the local area that can work on these projects and continuing to build out from there. But I think the most important thing, particularly for me, and I think running a social enterprise within the town is we're not just swapping one energy for another. We have to consider that we need to really change society as a whole as we do this, and we have to move away from that kind of extractive nature of the economy and just taking things from the ground. But we have to think about things that are more regenerative and sustainable in the longer term. And so the Just Transition movement is pushing towards that, and Athenry would fall into kind of the Midlands area that the Just Transition projects in Ireland are focused on, and making things a little bit more equitable, bringing along people from disadvantaged backgrounds, making things affordable for them as well. So some people just can't afford the energy upgrades at the moment, and how can we deliver ways that can support them to do that? And I think that's often something that's left out of the debate a little bit, but something that needs to be absolutely at the center of everything that we do. Because if we do consider it in them terms, and if we do think about ways of not just moving from one way of living into another, towns in rural Ireland have been derelict for a long time, and we need to look at ways that we can activate vacant properties. We need to look at ways that we can retrofit town halls and make everything more sustainable. And we need to look at ways that these energy mixes can kind of create these opportunities. So the money that we can generate from community energy schemes, pumping it back into the local economy and keeping that money within the local economy as well. So you can kind of fund biodiversity projects, or you can support communities to do something, take power and control over their local areas. And that's essentially what we're trying to do within Athenry. There's lots of pitfalls and hurdles, and we expect to meet more as we go along. But I guess if we don't have a vision for where we want to go with this energy mix, then we may as well just allow the larger corporates to run it and still be left where we're standing right now. So I think there's huge opportunities, and it's great that networks such as Galway Environmental Network are well aware of that and meeting up regularly to talk about these opportunities as well. So the more we push it as a collective, the more we can get out of it for everybody else. So thank you very much for your time, and my the web address there for the our project is on there as well.
Thank you so much, Patrick. That was a lovely and great overview. And we'll probably have some questions for you at the end as well.
Thank you.
Vincent, if you'd like to share your... Sorry, my dog's barking at the door, but I'll let you go ahead there, Vincent.
Not me, by the way, everybody. It's I don't go woof woof. Can everybody hear me?
Yeah.
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 Okay, thanks. So just I was one of the original mentors with SEAI. I think when we left the 350 SECs in the country. So one of many people who helped establish the SECs, and it's great to see it in Athenry at the moment. I think I suppose just mentioning Galway Energy Co Operative, of which I'm a co-founder here in the city, and Rethink Consumption. Well, it's a social enterprise. The cooperative is a cooperative. So I'm going to talk about household technology, initially community retrofit behaviour, and some community examples to give examples of what's going on around the place. Any figures I use are conservative. They could have been good 5 to 7 years ago. So I'm not coming up to current energy figures. So there's a lot more to be made out of than I will kind of attest to. So if you look at the figures far left here, the temperature in 1801, and the temperature is increasing with time to 2018 far right. Undoubted changes. The agricultural revolution far out left here, the industrial revolution at about 1800, 1850, and the spike due to cheap oil, it catalyzing the human population growth. So there's undoubted evidence of induced climate change that we're all kind of on board with. And I'll flick through some work on the ecological footprint, which I have done a lot of work on. Basically here you can see a settlement on top of an ankle producing emissions from all its behaviors and practices. The foot is the amount of land, it stands on the amount of land required to absorb those emissions. So the ecological footprint is a way of capturing our impact. Here you can see that food has a massive impact, almost half. Here we have 79 settlements in Ireland, broadly representative of the average Irish person. And we have a food footprint here on the left, which is about half. So each one of us here, roughly speaking, this is not a criticism or anything else, but to the average Irish person, if there was such a thing, you have about half of your consumption or half of your emissions are down to food. You could say about a quarter down to energy, and maybe a similar amount about waste. So what does energy use of the average house look like? What is the biggest energy user? Cooking, lighting, or heating? I could ask that question, but I figure most people here will have a good knowledge of that. As you can see here, I suppose I'm using a €1,500 sort of annual energy usage, you might say, for a semi-detached house, and about half of that is space heating. And the rest on the left here, you can see down to electricity, from computers to hot water, lighting, stuff like that. And within the electricity, you can see electricity consumption again in this semi-D house with maybe 2 to 3 people. Various components like the kettle, the fridge, the electric shower. Those are some of the larger things. So how to get on top of your energy usage? Collecting energy bills and scrutinizing them is a simple enough way. You can see a simple chart drawn here above doing that. Checking windows, external doors, vents, and those sort of gaps in the building. Drafts are a critical thing to cut down on. Checking insulation levels in attics, basements, and so on. Checking boilers and stoves, ages, and service levels. This particular house here, which house would you buy? I just, this is flicking on for me, but which I didn't intend it to, but which house would anyone like to buy a house here? Just you can have one of either of these houses. Which one do you want? The one on the left or the right?
Right.
Yes. You're picking the one on the right. Why are you picking the one on the right?
Left.
Okay, somebody tell me why you're picking the one on the right or the left.
I'm
Is
looking
that-
for the dryer roof.
Is that-
Insulation.
It's insulated.
Yeah,
Yes, so
the one on the right.
So Derek, yeah. So the insulation in the one on the right, as Derek is pointing out, is preventing the heat from the building melting the frost on. Similar here with the snow of this this 3-bedroom semi-D that I mentioned. That this is that building. So step 5 is to check. It's simple checks like that that enable you to work on, you know, excess energy use. Check lighting, numbers of incandescent bulbs, replacement with CFLs, LEDs. Effigies or OWL energy meters are very useful things you plug in on your side of the appliance that tell you what is being used, and these can actually through Wi-Fi and other in the home just plugged in. You can educate them to know when the kettle comes on and other things like that. They're well worth a look. Effigy or OWL. This one here, step 7, is in one you plug into individual appliances and allows you to know where actually the energy guzzlers in your home is. Identify how big standby is overall in your home. Check boilers and stoves, and maybe even go into a professional audit. And as we saw in Athenry, BERs are a useful device. So again, this building here, you can see that by turning it, these people have saved 36% of their energy use by a number of remedies, which we talked about with them, turning off everything and killing standby, using a clothesline instead of their dryer, washing clothes, investing in an eco kettle, which only boils, we boil a good bit more water than we actually need. Turning lights off, they had a fish tank, by the way, turning off lights when not in the room, replacing with CFL bulbs, and using oil to heat water. No electric immersion or electric shower used. There's a big saving on that at 24%. So just in terms of simple devices and simple ways of speaking to people, that's the sort of stuff we've done in the past. Just strike on some lighting, changing to other bulbs, because lighting accounts for 10 to 15%, as you've seen, of your bill. I suppose one of the main things here is if you use 4 CFL bulbs or 4 highly efficient bulbs, you can work with LEDs now. In the busiest sockets in your home, you can use 80% less electricity for those, in terms of lighting. So it's the busiest sockets you can focus on initially, and that's a critical thing. Drafts are a key thing. In the average Irish building, there's about a hole the size of a basketball in the wall. If you take all the cracks around windows and doors and places on the outside walls into account, this is sucking and it's helping air in and out of the house due to the chimneys in most homes and the stack effect, which is really like either emptying or pushing hot air out of the building. Depending which way you look at it, a number of remedies in around that are simple enough, as you can see here, from draft strips to silicone and the like. Curtains are another thing that can be overlooked, and you can see here how on the second from left, your energy use can go up with the curtain covering the radiator, and you can see right beside that a 21% saving. Where the curtain is tucked down inside the radiator. Window boards with curtains down to them next save between 10 and 20%. So simple devices like that. Ventilating your house, for a small amount of time, anything up to an hour, I suppose, as opposed to leaving the windows open, can make dramatic savings when you're airing rooms and things like that. Room thermostats or thermostatic radiator valves, sometimes reflective panels can produce, impacts. And maintenance of your boiler impacts of about 10% savings there. So room temperatures, by every degree you reduce, and again these figures are conservative. You by every 1 degree you reduce on the boiler. If you have a general thermostat on your boiler, you may save up to €350 per degree. The temperatures of stored water, let that be no more than 60 degrees, and there's good argument for less, but that would need further discussion. Bleeding radiators is an important thing, and turning off radiators 1 hour before you go to bed, for instance. These are ways to reduce, and I know with the Ukraine now, this is one thing. I just put in some slides here for Caroline that kind of may impact people's energy use, especially as the energy prices are going up well above what my calculations are here. So electric heating in general is hard to regulate, probably something we shouldn't invest in, though there is a new dimension to storage heating that is still I mean, it's still out, it's out there, and it's, you know, I'm not sure, you know, in terms of monitoring it, there hasn't been long enough time to do that. In your sitting room, standby is a critical thing. If you're buying a TV, LCD is the way to go. And some of your these digital boxes that don't turn off are a disaster. So the sky boxes are one that in general don't turn off. If you're purchasing Freeview, for instance, those boxes generally turn off, and they're a good thing. So these devices here, you can see a remote control with 4 or 5 socket devices around it, so that you can actually, sometimes you break your back to get behind the television to turn it off, and behind the stereo and things like that when you're going to bed. This is for that type of situation where you can plug that device in to the socket first, and then plug your television plug into it and your hi-fi plug and whatever into it, and the remote control will knock that off as you leave the room. It'll knock everything off. So that's another way of standby killers. If you're buying a new appliance, sust-it.net is a very good website. Or for comparing, you'll see that, you know, in terms of tumble dryers, refrigerators and washing machines, that there are massive impacts and massive differences. And if you do search on sust-it.net, please be careful. The first 5 to 10 appliances you'll see are heavily priced because they're top technology. But if you go down below those, what you get is a huge reduction in price without a huge reduction in energy consumption. So please be careful as you look. You might see a washing machine initially for 1,000 to 1,500 euro, but just drop down the list and you won't see a massive percentage reduction, you know, difference. And you get maybe a washing machine for 350, 400. It gives you something to go into the retailer with, armed as such. That's what that website looks like. From motor cars, it's starting to cover to all aspects of energy consumption, and that might help people. In terms of washing a full load, these are things that a lot of people would be aware of. Low temperature washing at 30 degrees. Detergents now are better than they've ever been, and there really is less and less need to have high temperature washing. Putting clothes out to dry, or not putting very wet clothes into tumble dryers, and similar for dishwashers as the washing machine. Pots and pans, using the correct size, and those type of stack devices are very useful as well. Microwaves are the most efficient way to cook. Kettles, here on average we boil twice the volume of water we need. So if you know someone who has everything, the Eco Kettle here is a very good present for them come their birthday. They don't cost a lot and they do save quite a bit. Fridges and freezers also. There's a lot of information here on that, and I might pass on this presentation to Caroline. It might be useful for people afterwards in terms of checking seals on doors, the thermostatic control of the fridge freezer. You can save a fortune in relation to the energy consumption of that appliance. In terms of draft proofing as well, floorboards as they join the building, Brendan would be very aware of this, are a disaster in the Irish borough build. There's a lot of leakiness in around the first floor level in terms of as they hit the cavity block or cavities, and not often fitted with great skill in the Irish build. So very drafty situations at the floor levels in building and ceiling levels that need to be kind of curtailed. There's a lot of information here in the bathroom. I'll just pass over as well, because maybe we can check that again. But the simple things coming out of this slide are not taking a bath and using 80 liters or 100 liters of water, but instead taking a shower and not leaving the shower on for 10 minutes. Try to take a 3 to 4 minute shower. Those type of things can save quite a bit of. This shower head as well saves up to €25 per year, and they can be purchased cheaply. The airing cupboard as well, there's very quick paybacks, often within half a year, on lagging your hot water cylinder. It really is a very inexpensive thing to be doing. Here we have structural changes in the home, looking at what should be done. And solar panels, wood pellet heating and wind turbines, they're really the last things we need to be thinking about. Initially, I'm an energy manager, and one of my hats, and the critical thing is to look at the structure of the building, because pound for pound, insulation and draft proofing pays back much more quickly than renewable technologies. So I'm a big fan of renewable technologies, by the way. I'm just trying to make this a financial win for people. The attic insulation, wall insulation, heating controls, an efficient boiler, lighting and appliances, and a high efficiency stove all pay back far faster than solar panels, wood pellet heating or wind turbines. And they should be looked at to get your envelope of your building tight and cozy. You can see attic insulation here at various levels. There are grants available and various types of insulation available. You can see pump fill cavity here, various things of pump fill. This is a bead, polypurl bead put into the cavity. It also helps cut the draftiness of the cavity as it touches the windows in around the Irish build. This is a pressurized insulation system, which is killing drafts in your envelope. So you have that type. And on the very bottom, you can see here we have a external insulation, which of course would be more costly, but again the grants are better. Here we can see some thermostats, some types of thermostats, costs of them around the building, and they make a huge difference. The open fire is approximately 20% efficient. If you buy 5 bags of fuel, 4 of them you are burning up the chimney without any benefit to you, and that needs to stop. It simply needs to stop. We can't afford to do that environmentally, and we can't afford to do that to people's health in terms of various respiratory elements, but we can't afford to do that to our pockets increasingly. A stove can be 75 to 80% efficient, and there is no reason in the world why this wouldn't be a simple enough remedy going forward. If you can't afford a stove or don't want to put a stove in, chimney closure devices should be looked into. Little more than €150. They will close the chimney, seal it, so that drafts between that basketball hole size in the wall and your chimney now are killed because you've closed the chimney off. Talking about renewables, it was mentioned in presentation that they're free. We have solar water heating, solar PV. We have wind producing electricity. Some people put that into heating and various other forms. Of course, where wood is replenished, it's renewable. So wood log burners and wood pellet boilers and so on and so forth. Here you have a simple solar thermal system, a cylinder, you have 3 panels. And it's you have the system also being contributed to by the boiler. In the summertime, maybe 80 to 100% of the domestic hot water fulfilled. Over the year, about 60% at our latitude and longitude. Here we have panels on roofs, here we have both the flat plate and evacuated in tube panels in the picture. There's a rule of thumb really, but you should never, you should size solar heating, to your maximum demand, which is, sorry, your maximum, the maximum gain, which is in the summertime, obviously, otherwise you're going to be heading for trouble. So solar PV then, as the gentleman mentioned earlier, I think it was a battery he had up to 2 kilowatts, he could increase it to 5. Costs are now currently maybe 1,700 to 2,500 per kilowatt. And these things are, this house is in Menlo. It has 4 250 watt panels on the roof, so 1 kilowatt. So it has 1 kilowatt of panel installed, and that house will produce about, for our latitude longitude, about 900 kilowatt hours a year. So 900 units of energy produced by that house in a year, which is at 17 cents a kilowatt hour is about 153 euro per year. This particular system in that house was bought in Galway City from a builder provider for 1,200 to 1,300 euro. I think it was 1,250, and it was installed by a builder. The builder was working on the house. Getting grants and one thing another, paybacks are between 5.2 and 10.5 years. This passive house here didn't require a grant. It's a new build and didn't have a grant rather, and it put that system in. So you've wood heating log stoves here that you put the logs in maybe twice a week, clamp it down, and off she goes. You can see your pellet boilers here also that are useful, and that they become an awful lot better. They can feed themselves, or you can just put them into the hopper on the top of that stove, and you probably get enough for maybe a day or two's use, depending on the amount of use that you the amount of heat you need from it. So log stoves, you know, 800 to 5,000 euro, depending. Log boilers about 15,000 euro. Pellet stoves 2 to 5,000. Pellet boilers 10 to 20,000 euro. Paybacks anywhere between 5 to 8 years, depending on heat pumps. Heat pumps are a device. I just moved to this. They're taking this particular heat pump is taking low grade heat from the ground, and it's putting it through the heat pump, which is in the building, and it's making it's producing warmer heat that it's circulating through the floor, as you can see in that on the red side of the heat pump. It takes the heat, low grade heat from the ground in terms of a vertical bore or horizontal piping, as can be seen here, but they can also work off air. The horizontal loops heat pumps, because there's excavation required, can cost between 17 to 20,000 euro. Running costs are low, incredibly low compared to what you're used to. They're not just providing the heat, you know, they're providing rather all the heat for hot water and for the storage, for the space heat in your home. Paybacks 70 to 20 years. This particular company here, I'll come back to heat pumps in a minute. It's necessary to do so. Renewables here, communitypower.ie. Someone mentioned electricity suppliers there. They should be looked into. And Energia, Brian Power. These guys buy power off small producers. They're the first utility company in Ireland to do so, set up to do that. And I'll mention them, probably mention them later on. So if you are buying electricity at the moment from any of the large producers, they will not buy electricity from small suppliers currently. They're not interested in small hydro, small wind, community hydro, community wind, anything like that in general. It's beginning to change, but these guys were the first. So there are very, very many free energy upgrades for those low in income. I'm not a broadcaster for that or a sponsor for it or anything. I'm not going to advertise it, but there are links, a simple Google of free energy upgrades. SEI will find them on attic insulation, cavity wall insulation, external wall, internal wall, secondary measures, boilers, and off and on windows. So it's well worth having a look. Arming yourself with information from the SEI website, and you can see some of the funding here for waged people as well. So money also provided for attic insulation, cavity wall insulation so far for those who are waged. In terms of heat pumps, you can see some funding here that is available. These things change from year to year, sometimes within the year. And I'm not broadcasting them. I'm just letting you know that there's a lot of grant aid out there really that you could be looking at. There is a deep retrofit grant that has changed its name. Is it super homes or super warm homes that a utility has recently taken over, and you can get your home. You know, in terms of retrofit, there's a lot of information out there. This particular there are grants, as I mentioned, for solar PV. You get about 900 euro per kilowatt. So if you go that route, you'd be paying costs of 1,700 to 2,500, I would imagine, per kilowatt installed. So really, when you get a grant, the price of it is reflected in the cost of the supplier. As I said, the 1 kilowatt system can be bought off the shelf in Galway for 1,200 euro. So 1,250. On solar PV, always look for a referral. They're on the way down, all those prices, and electricity prices are on the way up. It is a good thing to be thinking about, as previous presentation has said. In terms of what you offload onto the grid and what you keep, it's always better, and it will always be better to use what you produce, because you're paying 17 cents or more a kilowatt hour for the energy you produce. So don't be, you know, it's no big advantage to be selling electricity at 7 cents a kilowatt hour to Energia when you can save 17 cents from it. But obviously, when you have to spill into the grid, it's a disaster. That gentleman had a 2 kilowatt battery, which softens that slightly. So just to be careful about the economics of that. SEI have opened a community grant fund, and I'm doing some work on that for the Galway Energy Co Operative and Rethink Consumption. In Galway, we hope to put a BEC scheme together this year. with other stakeholders in the country. So if there are people here interested in retrofitting their homes or community halls or whatever it be, please let me know afterwards. I'm going to throw up some emails. I just worked through this. This was an older scheme, the warm and wellbeing scheme pilot, warmth and wellbeing scheme pilot. It's good. The reason I put this up is a good idea to keep an eye on these things, because SEI's pilots change, and it could just happen that we're in a pilot in a pilot area. There's funding, as you know, for EV chargers for the cars and for the cars themselves. This is well worth looking into. If you're in business, the Accelerated Capital Allowance Grant, I provide a link here for a quick look at that. The Exceed Grant also applies to people in business, and support schemes for renewable heat and so on. So these are important things if you're in business. To mention to everybody that there's a renewable energy support scheme at the moment, and we've had a first auction, and just to keep an eye on that, the government have put out a number of successful community schemes that are going to put solar farms on, and are in the middle of getting planning permission or installation at the moment. So this is a very exciting time to be in community, because communities are about to be paid for renewable energy. You can see here that the fuel prices are on the way up, but also are the carbon taxes. We went from 20 to 26, we went to 33.50 per tonne. The budget now is to 41 per tonne, and it's projected to 80 per tonne very soon. These are dramatic changes in the prices we're going to be paying for energy. There's a range of retrofit technologies I've mentioned: external, internal, wall insulations, seals and membranes, chimney closure devices, stoves, heat pumps, and so on. The heat distribution systems work differently. It's the technologies need to plug into those. You can see here top right, you have air and ground temperatures, and you can see how they reflect on each other. It's just a rough a chart of how the air temperature at any one time could reflect, the air temperature could reflect the ground temperature and so on. And it's why heat pumps perform so well when it is ground or groundwater as they're flowing into them, or the heat from those is flowing into them. We have a very useful report done on heat pumps for anyone considering moving. There was a lady on at the very start, I think her name might have been Jackie. She was thinking of moving away from oil and solid fuel towards electricity heating in her home, and heat pumps are the answer. But the caveat emptor, please beware, this is a fairly substantial heat pump study. There are 54 ground source heat pumps top left studied here, and there are 29 air source heat pumps studied bottom left, albeit in the UK. But it's similar here, and you can see what the system efficiency here is very important. You can see various efficiencies along the bottom axis, and you can see first of all that the ground source heat pumps in general are more efficient than the air source heat pumps bottom left. You can also see that you wouldn't really want an air source heat pump that wasn't very efficient, and the reason being, here we have a technology that might be installed for €10,000, for instance, in a home or more. Some might argue less, and you can see that the first system efficiency is 1.2 here. So for every 1 kilowatt of electricity you put into that heat pump, you get just 1.2 kilowatts out of it. If I move up to the ground source heat pumps, you can see that in the middle of the chart, you put 1 kilowatt hour of electricity in, 1 unit of electricity, and you get 2.4 of heat out. It's really important that you get these system efficiencies off the supplier if someone is providing you with a heat pump. These are very important, and most of the heat pumps in Ireland, would you believe it, haven't been standardized or certified. There is a standard, it's the EU standard 14511, and I just want people to be careful of buying renewables, and just make sure, ask the questions. If it's a good heat pump, you should be able to get a 3-year maintenance contract at the very start at a very low cost, and that's money very well spent. If you're buying something for €25,000, it'd be a very good idea to have a small maintenance contract to make sure that this a service contract, that this technology is going to work out for you for the next 5 to 10 years. So I have monitored heat pumps successfully, and we've ramped up performance, or anything up to 5. You'll see here we've a lot of data that shows heat pumps do work, but they also don't work. So just to be careful, we have paybacks for as little as 6 years, but there are paybacks that could equal 30 or 40 years on a heat pump that we have seen. One of our community projects was the SERVE project, and here we moved a house from a C3 to a B2. How did we do that? As you can see in the chart below, the existing house was a C3. The upgrade to the attic moved it to a C2, as did its upgrade of the cavity wall, and the hot water cylinder moved it to a C1. And you can see as you move down in the chart, what each kind of upgrade, what difference it made to the BR, moving that from, I think this is a useful chart, from C3 to B2 at a cost of €5,350. This is that house I showed you originally. This is a thermal imaging we got done on that house. And you can see where this house is very efficient, but where the chimney is still very red. There was, in that sitting room, they had a new stove insert in the chimney breast, which was used a lot to heat the home. But you can see the reddening of it. Even at that, it was inefficient in places. But in general, that building far more efficient than the one on the left, than the one beside it. Here in the SERVE project, we have a typical bungalow. I show these because they might be typical of some of us in this room tonight, moving from a D2 to a B3. And again, the upgrades, each of the upgrades below, which made a difference, and we starting with the upgrade to the attic, and you can calculate those differences out. The upgrade to the attic is one of the most efficient. There was various other remedies in this particular home, and here you have a typical farmhouse, a 2-story, and what can be done to move from an F to a B3. This particular cost was 17,000 because we had to upgrade the walls. But nonetheless, there are €1,900 savings every year to their energy bill. This particular house in Menlo, I showed you the other side of it originally. It's one of the airtightest houses I've met. Left alone, it changes its air contents about once every 2 days. So if you can imagine the air that leaves this home that you don't want to leave, it could be because of unnecessary cracks and sort of openings in the building. The air is leaving this home and coming back into it, and it's diluting the warm air in the building. But that happens, roughly speaking, it changes its complete air contents once every 2 days. And you might be saying, well, that's not that efficient. But there are homes in Ireland, and we may be living, some of us in this room may be living in some of them that change their air contents once an hour or once every 2 hours. And we really have to change in terms of air tightness. We really have to build homes that are a lot tighter. I just need to move that out of the way there. Sorry. So there are some, and I'll quickly go through some community examples now. But there's some reading here. The first URL at the top is 11 houses in County Galway that we BER'd, and that we looked at how to retrofit those and change them, and they make it very simple. And then the next link is in Galway City. It's the Galway Energy Co Operative work. It's part of our energy master plan, but nonetheless, there's a number of houses in there in the city. And so you have the city and the county there in those 2 first links. Look at the houses, look what's similar to your own, and possibly think about where you could make changes. There's some reading in the other links in terms of energy efficiency. I can go on and look at the footprint in some other community buildings if here I've another number of slides, but I don't want to do that without permission. People might want to talk. I don't want to go too far. Obviously, I'm knee deep in this stuff. I can stop now.
What we might do is just take a couple of questions because you covered loads of stuff there, and we'll come back to the next bit if you want, if people are still, because I'm afraid people might want to leave or anything, or have other things to do, but maybe they have a couple of questions they'd like to, so maybe put your hands up, your reaction hand or whatever it is, if anyone has a question. Niall Murphy.
Hi Caroline, thanks for that. And thanks Vincent, and thanks to all of you for the presentations. The thing I'm curious about actually, it was the earlier speaker, I think it was Patrick, who talked about Athenry and the community energy the scheme there. And he mentioned in one of the slides residents associations and tidy towns and so on that sometimes are the groups that choose to get involved in this area. And I kind of was just curious about how difficult or easy it is to build a community on that. Do you need something that already exists, like a residents association, to have a sort of a ready-built community with all the connections in order to get people to buy into this? Or do you know how difficult it is for people to establish energy co-ops without sort of a predefined social structure there?
Well, I think it can be used as a catalyst for that on its own. So, you know, every community will have its own groups and organizations in place already. But I would see that the sustainable energy community could be something that either starts as its own project and bring those groups together, or it allows, you can start it from scratch as well. But typically you would need some people on the ground that are really keen to do that.
Yeah, and just sort of follow on question, when you say really keen, I'm wondering what level of technical expertise is involved, or like you mentioned that the master plan was something you contracted out. Is it really about people who know how to apply for grants and do the paperwork, or does it require a certain amount of technical expertise?
No, like to be fair, the mentors are really, really good. So they do an awful lot of work with you just to get you up to speed on what you need to submit. And the application form itself wasn't too onerous. It's fairly straightforward to get to that master planning stage. And then that's when the kind of energy experts would come in as well.
Okay, thanks.
Cool.
Brendan there.
Yeah, just a question for Patrick. Patrick, you mentioned you had a 2 kilowatt battery installed, and you showed some very interesting graphs of your power use during the day.
Oh, that's Jimmy, I think, is it?
No, I think it was Patrick. Sorry, I'm wrong.
Jimmy,
Jimmy,
yeah.
sorry. Jimmy, you showed some interesting graphs of your power demand or power use during the day before the electricity, before you did the installation, then afterwards, and you could see how much lower the graphs were. But the battery pack, is that meant to kind of cater for your base load overnight and that sort of thing, or what contributions does the battery make, do you find?
Well, yeah, I mean, I'm producing so much that it tops up the battery before it starts putting it into the grid. So to me, at the moment, the grid is a complete waste in one way, which is hopefully I'm going to start getting paid something for that. But as I said before, when my meter was going backwards, that gave me the sort of the real picture that could be achieved if you can actually have negative weeks during the year where you're actually putting more power back into the grid, or making your meter go backwards rather than actually turning than getting the money back. As I said, the power that's going into the grid at the moment to me is a loss. Now, as I said, I'm looking at Energia, who talking about paying me 7.5 cents, but at least that would be something to get back rather than have nothing back out of it as such, like, you know. But the battery, obviously, at the present time, the battery, well, since the time has gone back, the battery is getting better because I'm still getting more time in the evening. But during the winter times and in the springtime, the battery is really probably taking care of part of my tea time preparations and my cooker and all that at that stage. But now, as the days get longer, that battery won't be coming in until the light goes, which could be 7 or 8 or 9 o'clock at night. So it like prolong my credit situation as such.
Very good. Okay, thanks, Jimmy.
Thanks. John?
Yeah, just a few points. People mentioned, you know, community generation, community power, and I was with them for a while, and they are excellent, but they ran into a problem which might affect other cooperatives as well, which is that they could not provide all their power from their own generation, wind farm, etc. So they had their prices almost trebled over a matter of 2 months, and I had to resort to one of the larger ones. And this is a problem that could affect other energy co-ops, and I'm not sure they were, for instance, prevented from building a solar farm. I don't know what the holdup was. Secondly, Vincent mentioned stoves, and I just worry about stoves because they're not that efficient. They're more efficient than open fire, obviously, but they generate carbon dioxide, etc. And the mention of solar thermal, I can't see that solar thermal does anything now that solar PV can't do. And to me, solar PV is quite competitive. It's payback 7-8 years, probably down to 5 years with the way electricity prices are going. So just, I think we should be utilizing all the sources at our disposal. One of the things that strikes me is people don't always realize how much energy is in a kilowatt hour. Like if you lift 10 tons through 10 meters, that's a megajoule, and a kilowatt hour is 3.6 of those, which is a massive amount of energy. We don't really think in terms of that. So any energy source we have available, we should harness. And the last point is energy storage. It's been largely forgotten about in the Irish context in particular, because we're going to have to use either a massive pumped hydro scheme or nuclear or gas to provide the backup, because renewables will always require 30 to 40% backup, no matter, to cater for the times when the sun is not shining, the wind is not blowing. So this is something that the country needs to really focus on. Okay, thanks.
Thanks. Did you want to answer any of that, Vincent, or were you happy?
There were a lot
Any
of
other things that John was?
Apologies, there were a lot of points, and my short-term memory is shot at the moment. But in terms of community power, if you wind the video back far enough, purchasing renewables off small producers is a very good thing. Providing electricity to people at the same cost as the other utilities is a good thing. I accept his point that they've run into difficulties, but like that, sustainability isn't simple, and they may very much return back to a situation where they are producing power cheaply. His comparison of solar thermal and solar PV is based on financials, and I'm not going to argue with that. Solar PV is becoming more affordable, you might say, more, so I can't argue with that. Solar thermal has a place. All of the sustainable energy sources have a place, and I think the switch to gas is a necessary in terms of storage. Our cooperative has a project which is looking at storage. It's an Interreg project, and I can provide details later on. But there is hope there. But in terms of initially, there has to be a switch to the most efficient fossil fuel. As much as I hate the idea. And that's gas initially, in terms of shifting and replacing or backing up renewables. But we've never been in a better place in terms of renewables and PV coming down, somewhat offshore in terms of wind and storage. Storage is it's positive for the future. We have some huge examples in NUIG. Rory Monaghan and others working on hydrogen storage, which is a bit. He wouldn't say it's futuristic, but these things are moving, and hopefully we can all, contribute a little bit. I can't remember his other points. Sorry, Caroline.
Or Damien Quinn there, thanks.
Yeah, so it's interesting listening to you all. I suppose my previous employer had one of these windmills, and he'd often complain about how much it was costing him every year, do you know what I mean? And it was strange that like a renewable energy source would be costing him so much money. But I really like the hydro kind of renewable energy things, there's a constant flow of energy that we can tap into. But I suppose the question I would have is for just James, you have additional kind of energy, let's say, once you've got what you've got from your solar panels. I suppose, would you be more interested in kind of making a few quid on that, or would you be like open to your neighbor getting the additional, and that type of thing, the circular piece? I'd be interested in that.
Yeah, I mean, at the moment, I would go either way. I mean, as I said, to me, it's what's going back into the grid. It is technically helping somebody else out because they're using up the power somewhere along the line. I mean, it's only a microscopic part of what, say, the ESB or whoever it is providing for the year. But if there's enough people like me, it starts to become a significant thing. So either the general community in the country are benefiting from it in a small way, or else if there was a way of putting it, sharing it around amongst the neighbours, well, then I'd be well open to that idea as well, sort of thing, It's just that, as I said, for the last year, I got nothing for it. Now there may be a possibility I am actually going to get something for it, but it's like Tesco says, every little helps. Basically, that's the way I look at it.
Yeah, well, I suppose like not putting you on the spot or anything, like, you know, but I suppose if I had additional energy and like if I was getting what I paid for, which was a complete reduction in my outgoings, in an ideal world, I'd like to be able to share that with those that need it most, kind of thing. And I suppose that's where we're all kind of heading, is kind of a more kind of an equitable approach to these things. And yeah, that was just my question. All right, thanks.
Thanks. And Neil Goodwin.
Thanks, Caroline. Yeah, just a couple of comments on batteries. The system I have at the moment, it looks like I'm going to be averaging dumping about 10 kilowatts a day back to the grid. So at the moment I'm on a night rate meter, so I'm not going to get any payback. I don't have a smart meter installed yet. So that's one of the reasons. And of course, the rates that the utilities are paying for electricity on the smart meters is hugely different to what they're charging up for the smart meter rates is much greater than what's being charged on the domestic or the 24-hour meters at the moment. So I want to try and hang on to that night rate, and I want to try and hang on to all that energy I have. So I'm looking at trying to capture that 10 kilowatts. So I'll have 15 kilowatts of batteries. That should get me off the grid for most of the day. But the other advantage of the battery and the power storage, of course, is in the winter time on the night rate, I can charge up those batteries on night rate electricity, which is very cheap. It's also majority generated from renewables, from wind. So you're using that that power source to charge up your domestic batteries, and then you're surviving off those domestic batteries when there's a much greater use of carbon generating going on the grid in the daytime. So it's economic, it's also environmental, the benefits of the batteries. But just one thing that struck me early on, one of the first speakers talking about community groups and community power. I was wondering, is it feasible for community groups to not even buy, but to be allocated the power that is being generated by the microgeneration systems within their community? So if I was dumping 10 kilowatts to the grid in a day, could I allocate that to, rather than giving it to Energia or giving it back to the grid, could I allocate it to Athenry Community Energy Scheme?
Currently, the answer, currently Tala, Duncan Stewart's brother, is working on a project in Tala, and there's a project in Limerick that is looking at this microgrid thing, and looking at, you know, that the type of exchanges of energy that you're saying from one house to another, to a business, so on and so forth, electricity wise. So that's all, I think you could almost say experimental or being tested and piloted.
And I think for the interim as well with community power, they're that link as it is without the need for that kind of micro generation, or at least until it matures a bit more.
That's very interesting, all right, as well, about, you know, sharing your excess electricity, even with your community groups who might be struggling to pay for the electricity of the local hall or whatever, you know. There was another question there, Seamus. Sorry, Vincent. Did you want to come in there before Seamus?
Yeah, if you don't mind, if you think about what happened in Derrybrien with the ESB, you know, recently been in the Irish Times, back where there was that bog slide, and they came in with they wanted to put 70 turbines on a piece of bog, and they didn't do an environmental impact statement, you know, many years ago, and now that's been refused, substitute permission by on board Phelan. This is the ESB who straight after the bog slide in Derrybrien introduced a moratorium on wind, which impacted one of our community wind farms. So the ESB there's a huge inertia within the ESB, and microgrids and all these newfangled, you might say, things that they're looking at. And they're not my words, you know, but there's an inertia against change, and they were the very ones that produced the wind moratorium initially. So it's very easy to be cynical about these things too. So it has been too slow. The change has been too slow.
Very good. So go ahead there, Seamus.
Thanks, Caroline. Yeah, I just wanted to ask the speakers, I don't know which one would be best, but about inverters, because they seem to be prone to breakdown or failure. A neighbor of mine has an inverter gone, and when my system was installed, I was offered, a warranty, of kind of pay for an extra warranty, which seems to suggest to me that they were fast moving things. And also I've heard that the more micro generation there is on a line, the more likely the inverter is to go. So can anyone tell us what makes inverters go and how likely is it to happen? And thanks.
Who can answer that question?
I haven't personally, I haven't come across problems with them. I have seen a lot of successful cases, and I was mooting in my own presentation in relation to heat pumps having a 3 to 5 year service contract with any particular new technology you take on board. If the technology is really good, and if the salesman is telling you that, saleswoman is telling you that, it's a good time to be getting a service contract and a deal on it. And therefore replacement of parts at no cost to you if anything goes wrong when they need to sell, as opposed to afterwards. So I just think with renewables and new things like that, inverters, that we need to be just as financially kind of clever as if we were buying anything else.
Okay. And I suppose the other thing is, I think you were saying, Patrick, that the community, the SEC community projects, they link in a lot together as well.
Yeah. So there's a lot of knowledge sharing.
That's a really good, like knowledge sharing is vital in all of this, and that's why I thought it was important as well to have Jimmy, and the personal opinions from people, because I think people's personal stories and experiences are important. And nights like this, and Vincent, your own presentation with all the stuff of, what we can do before we even go down the renewable energy line, or what we can, what we can do in our own homes is vital for people, especially now with the rise of energy costs. And Michael Scott has a question there.
Thanks, Caroline. Thanks for everybody's presentations. It's all really interesting. Just a question for Vincent there. Is there any movement on hydropower in Galway, considering the role the canals have played historically in Galway's past? I've heard said before that it was one of the first cities in the country to have electric streetlights powered off the canals. And just on the house on Menlo, just if you would mind briefly just saying what works were done to make it that as airtight as you said it was there.
Okay, no problem. I'm just going to try to get down to another picture of it if I can, so just to help with that question. Or maybe I deleted it. Sorry. The house in Menlo, there is, I can't see it and I can't multitask. So I'm just looking for the pictures on it, but apologies if. So if you can see that, the house, in terms of its design, design is important. I mentioned the joists meeting the rafter and the wall plate. It's a very difficult joint to seal, and you have to seal it so many times because you have a lot of rafters. So in this particular house, the joist meets the wall and the rafter meets the wall plate, and that's all separate. So there's a design at a very kind of critical point in the building where there's a lot of leakiness, that is the wall plate, whereby the wall plate only takes the rafter and it's sealed accordingly, but the joist itself is lower than that in the building. It strikes in the inner leaf of the cavity wall. That's one of the things. Obviously LED lights and that type of, there's a high passive solar gain on the back of the house. There are high levels of insulation, as you'd expect. The thermal bridging has been fairly designed out of the building at a number of points. It's heated using a very small air source heat pump, one of the smallest that you can kind of purchase. Little more than a, use a little more than a kind of a large light bulb. Wood burning stove that was one of the points John made about wood burning stoves. There are so many fireplaces in Galway City burning coal, John, and burning fossil fuel across the country, that a wood burning stove 4 to 5 times more efficient in many ways. Not just due to its effect on burning the fuel, but on the fact that when it's not burning fuel, the house is now sealed when the damper on the stove is closed. So in monitoring the wood burning stoves, they are hugely efficient. The particular stove in this house is a DEFRA one that is kind of low in NOx. It's certified to be low in NOx. It has 1 kilowatt of solar PV that I showed earlier on the back of the house. So you have electricity being produced that is little more than the house. It is less than the house uses. So there's virtually no export, and the total electricity cost for the home is 4,000 kilowatt hours per year. Now that is the heat, the light, the cooking, and the house has an EV. So the solar PV, when it is in excess in June and on the shoulder months, May and July, is going into the battery of the EV and it's stored there. So just in terms of its performance, it's a house that costs no more than other houses to build in terms of its square footage and all that. It's nothing. It looks like a cottage, as you can see, but it's just got a whole load of more kind of designed in efficiency items.
Okay, thanks very much. Stephen, and I'm conscious of the time, it's now 8:30, so.
Actually, yeah, Vincent just touched on it. I was going to ask about using EVs, using the battery in EVs when they're just standing in the driveway doing nothing. Is it possible in Ireland now to actually tap the energy that's stored in your vehicle to run things in your house?
That's a great question. I think that really is. That's the Nissan have a trial in Norway and the UK at the moment, and they're demonstrating this, that power can actually leave. Now, not in the standard EVs on the road, but in this version that they're using, Stephen, the batteries can be biflow, and so they will provide new generation batteries will provide power back to the house, so that you can do that. I think the Nissan van, it's kind of I forget the exact model, but there's a Nissan van that looks a bit like the old Nissan Vanette. It's not a huge van, and as far as I know, it produces 1 kilowatt of power out of its battery. It's an EV, for like marketeers and people in stalls that need lights on their stalls, and say in the markets.
Perfect. Right.
As far as I know, there is a version of that van, but it's a start, and it's a great question, because I think that's a game changer.
It seems stupid not to do it if it's possible. Yeah. Thank you.
Thanks very much. Do you have many more slides, Vincent?
They were related to community kind of stuff. There was some on the footprint there, and people probably have a partial interest in the footprint, but just quickly, this is the footprint. No, I do them very quickly. This is the footprint of a community of about 2,000 people. You have home energy use here at the top. You have their waste consumption on the right, food consumption in the car, and that's the size of it at the start. It's about 3.77 global hectares, and as you reduce down from year to year, there's a 28% reduction, especially in waste, as you can see, and home energy use in cars. So we've worked with communities on behavior, like behavior stuff like that. And here, there's another, that's Clock Jordan's, but this is the wind turbine project that Community Power has arisen out of. And this is their project. I had a chronology here of what happened to us when we were setting that up. But it currently is 4.6 megawatts, and it is turning. It roughly has paid the banks off, and it has It is now produced Community Power, the utility company, which we mentioned, and John had to leave because they got very expensive as they did. And this is the share offering to the community. There were two to the community, 27 individuals invested in it. And the Tipperary Energy Agency, where I worked, we give our labour, engineers like myself and others, we give our time. And now the Energy Agency has a 1/30th share of the generation of the turbine. So that's how that worked. Drumban Upperchurch is a community. Bottom left, these are communities from all over Europe that visited. They retrofitted themselves, their buildings. They reckon their energy bill was €1 million per year, and they've reduced that by approximately, I would say, 50%. There's a lot of homes retrofitted in Drumban Upperchurch. You all know about Clough-Jordan. This is its layout map. You probably don't need to look at its district heating. It's wood chip, it's farm, and it's transport. It's various things. Inishmore, I was going to look at Inishmore Island and some of its renewables. And I guess, that's it really. That's what I had. Caroline, thanks for the opportunity.
Thanks so much. Just so much stuff there, Vincent. And, I think we'll have to revisit energy again, because it's, there's crucial information in there, whether you're ready to get solar panels or whatever it is, or heat pumps, but even just to the point of insulating your houses, and getting it airtight or whatever. I think there's great points there to be made. And thanks so much to everybody for all their points tonight. I don't know if anyone has any other questions before we go, or any points to make that they'd like to make. Thanks very much, Jimmy, for giving us his perspective, his own personal, and Patrick Mulvhill for the Athenry SEC information, and Vincent for all your information from right down to the individual home and all the changes you can make, and up to the community projects. And I don't want to keep anybody any longer, because it's a long time, but it was really, really interesting. Thank you so much, everybody.
Thanks, everybody.
Thanks, everyone. Thanks, Caroline. Thank you so much.
Thank you so much yourselves.
Thanks, everybody. Bye-bye.
Really good.